Oh, guys, are you getting pumped? It's math time. Math! Math, math, math. Okay, I'm just messing. Hey, this is the Bourbonation. Here's lesson 9.2 from my living room. We're going to talk about how we can solve quadratic equations by using the graphing technique. It's not going to be too bad, but it's going to be kind of icky at times. So when you don't understand something, you got to make sure you ask for questions, for help. Check me out on Schoology. Just don't be shy. You're gonna YouTube things, do whatever you need to do to figure this stuff out. So there's different types of answers. The answers when we graph quadratics all are about when the parabola, the U-shaped graph, crosses the x-axis. So these are called the roots. So the two solutions happen when there's two lines that look like this in a graph. One solution is when we cross only at this one spot. This is called the double root because it counts for both of them. And then there's no solutions if it never crosses at all. Now, when you get into Algebra 2, they'll talk about other ways to figure out solutions here, but we're in Algebra 1, so we don't got to worry about that. So let's get rolling. This video might be too long the way it is, especially if I get too crazy about my music. All right, so steps to graphing. Make sure, number one, that you're in standard form. That's where you have, just like we did in Chapter 7 and Chapter 8, it looks like this. This is standard form. Make it equal to 0. Step 2 is we're going to graph all those pieces that we did in 9.1. So we're going to get fired away here. So to find the axis of symmetry, we use the opposite of b over 2a formula. In this problem, that means we're going to have b, which is a -3, the opposite makes it a +3, over 2 times 1, because that's your a, which means that your x is equal to a 3 over 2, or if you want to call it a 1.5, that's cool. So when I graph that, x is equal to 3 over 2, or 1.5, I'm going to go to the right 1.5, and I'm going to draw a vertical dashed line at 1.5. Now I draw that all the way through my graph so that I know that's the halfway point. That's where we're going to fold things. Ooh, I got a new email. Step 2 is to find the vertex. So to find the vertex, we have to plug this x back into the problem. So when we plug it back in, it's going to look like this in your calculators. You're going to type in parenthesis a 1.5 to the second power minus a 3 times a 1.5 and then minus 10. Now that, when we do that, and I'll do it in my calculator too, we get ourselves a negative 12.25. So that means that my vertex is at a 1.5 comma negative 12.25. Now that's a pretty gross number, but for my graph it only goes up to 10 here, or down to 10, so I'm going to count by 2's. 2, 4, 6, 8, 10, 12.25. So I'm just giving a good old-fashioned estimate down there because the things that I care about are where are they going to cross the x-axis. So if my vertex is down here, the graph's going to go up like that. So we're going to have our next steps is to find the y-intercept. So from 9.1, finding the y-intercept is when we put a 0 in for x, which means my y-intercept is just equal to that negative 10. So I'm going to go over here down my y-axis. I'm going to go down 1, 2, 3, 4, or I'm sorry, 2, 4, 6, 8, 10. Now because this is a parabola, I have a matching point on the exact same distance away from the axis of symmetry. So over here is my other matching point. So I know that my graph is already going to do this. Okay, now my next step is to kind of make a little bit of a guesstimate as to where we think it's going to get all the way up to the x-axis. So I'm going to guess that it's not this first line, but the second line. So that's 1, 2, 3, 4, 5. That'd be my best guess. So that means I'm guessing that 5 is going to be my number. So I'm going to plug a 5 into this where it says x squared minus 3x minus 10. So when I plug a 5 in, it's going to say 5 squared minus 3 times 5 minus 10. And I'm going to figure out what that equals. Now, if it equals 0, I have hit the jackpot. So hopefully that's what it is. I like it when I guess correctly the first time. So if I do parenthesis 5 parenthesis squared minus 3 parenthesis 5 and then minus 10. All right, I got it. So I got myself to a 0. That's exciting. So that actually equaled 0. That means that when I go to the right 1, 2, 3, 4, 5, here I am at 0. So I know my graph does this. That's pretty poorly drawn, but it hits that spot. Now what you want to see is that I'm going to have an exact matching spot on this side that's going to be 1, 2, 3.5 spots away from my axis of symmetry because they have to match each other. This line is the middle line. So here's my half. 1, 2, 3 is my other one. So my graph now is symmetrical. I did an equally bad job of drawing that time. And my last step, folks, because I'm really bad at drawing, is just to double check. Step 3, check your solutions by factoring. So this is where we use our skills from chapter 8. So we had the problem of an x squared minus 3x minus 10 equals 0. If you remember this from last chapter, we're going to take a factor tree thingy here. I'm sorry, a table. And we're going to say what multiplies to make that negative 10, and then what adds to make the middle number of negative 3. So we already know that because this is negative, one's going to be positive, one's going to be negative. And we know that 5 and 2 are our magical things. So to make it negative, we have to have a negative 5 and a positive 2. So that's our one that we're going to use. This, because it's an x squared, not a 7x squared, goes straight to our answer from chapter 8. So we have an x minus 5 and an x plus 2 equals 0. Which means when we do x minus 5 equals 0 and x plus 2 equals 0, to solve, we find out that x is 5 and x is negative 2, just like what we said. So we know we've done things correctly. So we've got our answers in the right spots. We've done all 3 of our steps, and we know that we are correct. Now that's how these problems work. This one is the exact same process, except for we have to make it say x squared, make it say equals to 0. So we have an x squared and then plus 16 equals 0. And then we do the exact same steps as we did on the previous problem. So I'll tell you that the answers for this guy, I'll just give them to you, are at negative 4. So check this out. So step 1 is to find the axis of symmetry. So we know we're going to have stuff at negative 1, 2, 3, 4, because that's what we just told you the answer was. So axis of symmetry should be right here at negative 4, but we'll find out. So we plug the numbers in. Opposite of b is a negative 8, and then divided by 2 times 1, which is 2, so the answer is negative 4. When I go and plug in my vertex, so I have an axis of symmetry right here. That's beautiful. My vertex is going to tell me to plug this number back in. So I take my trusty dusty calculator and I plug in just like this. If you don't use the parentheses, you're going to end up screwing stuff up. It's a negative 4 squared plus 8 times negative 4 and then plus 16. So when we type those things in, we should get to a 0, I believe. A parenthesis, negative 4 parenthesis squared plus parenthesis, 8 parenthesis, negative 4 parenthesis plus 16 gets me to 0. Jackpot. Now because my vertex was at 0, I have a 0, 0, I know that this guy right here is just going to be my answer. I can just really do that kind of stuff, except for I know that my y-intercept's at 16, so I need to get that, undo that. We got to go to 16. 2, 4, 6, 8, 10, 12, 14, 16. So I know it's going to be a nice U shape going up that way. And I am 1, 2, 3, 4 away. So 1, 2, 3, 4 away over here is my other matching spot because they're parabolas. They're symmetrical. And that's what my parabola should look like. And we know we're correct if we factor this bad boy out. So we have an x squared plus 8x plus 16. We're asking ourselves, what multiplies to make a 16 and adds to make an 8, which is the 4 and 4. Oh, my kids are back inside. So now we have an x plus 4 equals 0. And that's how we do the math. Hey, boys! All right, so now that we have ourselves in that spot, our two answers are going to be x plus 4 equals 0 and x plus 4 equals 0. So we find out by solving that we have a negative 4 and a negative 4. So that's just a double root. That's why it's called a double root when I talk to you on the very first page. All right, here is another one. Now, of course, I'm going to give you an example where the information doesn't cross the x-axis, because what else would we do as teachers? So when I do this one, we're going to find out again our axis of symmetry by doing the opposite of b over 2a, which is a negative 1. So I have a vertical dashed line at negative 1 here. And then I find my vertex by plugging that bad boy back in for x. So that gets plugged back in. So this is where you take that calculator again and you put in your parenthesis, negative 1 squared, and then plus 2 parenthesis negative 1, and plus 3. Now when I did that, I got the answer of 2. So I have the ordered pair of negative 1, 2. 2 was the y value, so I'm going to go to the left 1, up 2. Now if my vertex is this way, and my y-intercept's at 1, 2, 3, that means I have another dot right there because they're symmetrical. It's going up like this. We are not going to be crossing the x-axis at any point in time. So if I were to factor that, you're going to find the same exact thing where it doesn't cross the x-axis. It's going to be one of those no solution ones. So we're asking ourselves the question of what multiplies to make a 3 and adds to make a 2, and we find ourselves this. We have an x, so we have no possible way of making a positive 3 and adding to make that. So this one is just, it's done, it's factored, it's prime. We can't do any more. So that's how we know that we're good here, folks. All right, now here comes the hard one. Now on this bad boy, it's not going to be a nice integer answer. That's what these integral roots mean. If we can't find a nice integer answer where it crosses the x-axis, then we have more work to do. So if you thought that other stuff was confusing, I apologize. Here comes more confusing stuff. So same exact process. We're going to take and find the axis of symmetry. Opposite of b is 4 over 2. So we have an axis of symmetry of 2. So I go to the right 1, 2 spots. And I make a nice, beautiful vertical line. Now my vertex, I plug that back in. We have our x squared, which is 2. So parentheses 2 squared minus parentheses, minus 4 parentheses 2 parentheses, and then plus 2. And that gets us to the answer of negative 2. So that means I have a vertex of 2, negative 2. So I'm going to go to the right 2 and then down 2, and that's my vertex. My y-intercept was at 2, so I'm going to go up 1, 2, and I have a dot there, and I have a dot here. Now, as I go up here, you'll notice that these things are not crossing nicely. So my spots right here are not crossing very nicely. So to give myself a nice super answer, I can't. So what we have to do now is we have to find exactly, and it's going to be a lot of calculator work, we have to find exactly what those numbers are to the best of our abilities. So we'll know it's between 0 and 1 for this one, and between 3 and 4 for that one. So the way we guess this is just by making a table of values. So we know it's between 0 and 1. So you're going to make a chart of 0.1, 0.2, 0.3, 0.4, 0, 0.5, 0.6, 0.7, 0.8, and 0.9. And we're going to plug those numbers into our calculators. What we're trying to find is when the number goes from a positive to a negative or from a negative to a positive. Now, just off of my sketch, this looks like it's about halfway between. So I'm going to start at 0.4. That means I'm going to plug 0.4 into this, and then I'm going to plug in 0.5 and 0.6 and see what happens. So in my calculator, I will have those numbers that get plugged in. So I have parentheses, 0.4 parentheses squared, minus 4 parentheses 0.4 parentheses, and then plus 2. And that answer was 0.56. So underneath the 0.4, I'm going to write down a 0.56. Now I'm going to plug in the 0.3 actually, because if I go bigger, I'm getting closer to 1, and that's getting down farther. Actually, no, I want to plug it in the 0.5. We were just on a positive side. We want to get to a negative side. So plug it in a 0.5. I'll do the exact same things. So it's parentheses, 0.5 parentheses squared, minus 4 parentheses 0.5 parentheses plus 2. And I got a 0.25. So we're going in the right direction. We're getting closer to 0. So this one now says 0.25. 0.6 might be our magical number here. So now we'll do the exact same thing. Parentheses 0.6 parentheses squared minus 4 parentheses 0.6 parentheses plus 2. And boom, we got to a negative 0.04. So negative 0.04. So we know it's between these two numbers. It's between a 0.5 and a 0.6. And you can see that this number, 0.04, a negative 0.04, is closer than a 0.25 is to 0. So I'm going to estimate as a 0.6. So one of my answers is going to be a 0.6. Now we'll do the exact same thing on the other side by guessing and checking, or we could also even do this. Because we know that 0.6 is a certain number of spots away from our axis of symmetry of 2. We can do 2 minus 0.6, and that's a 1.4. So if I add 1.4, so this is 1.4 spots away from where it crosses. If I add 1.4 this way, I would be at 3.4 for my other answer, because they have to be symmetrical. Now I know that this is going to bring up a bunch of questions for you. The homework assignment for distance learning is going to be mostly the other kinds of questions. Make sure you check things out on the Schoology. You'll be able to match your answers carefully. And again, if you don't understand something, please ask questions. We're here to help. I mean like me and my other personalities. So this is the Bermanation. I'm keeping it real. Have a good day.